In this module, we look at the engineering properties of timber. Timber is an engineering material, and like all other structural materials, it's characterised by properties. So we'll look at these properties. These properties are indicated by a stress grade. And of interest to us as structural designers is the characteristic modulus of elasticity and a suite of structural strengths. Also, after we've designed the members, we've got to join them together. So it's important that we understand connection strengths, and that's indicated by joint strength groups. Stress grades. Timber is a natural product. It grows. As a result of that, instead of having a recipe for creating a piece of timber, we have to take a natural product and classify it into different groups. So for sawn timber, a stress grade is a grouping of pieces of timber that have similar structural properties. So it's sorted into stress grades using some quite advanced technology. Nowadays, in a modern sawmill, there are banks of computers that are assessing and measuring different character in every piece of timber to classify it into a stress grade and a strength group. Those properties of the product are confirmed by testing on samples, so that in the end, the structural timber has a consistent level of reliability. All of the properties are indicated by the stress grade associated with each piece of timber. On the other hand, we create some structural timber products by taking timber fibre and gluing it into engineered wood products. So using engineered wood products, we're using a large number of different pieces of timber or wood fibres in a piece of timber, all glued together, and a recipe can be used to create a product with appropriate structural properties. Again, once engineered wood products have been manufactured, there's testing that establishes that the properties for each stress grade are actually being achieved. The stress grade is marked on each and every piece of timber, and they are linked with a full suite of structural properties, which includes modulus of elasticity, the stiffness of the timber, how much it's going to deflect under load, its strength in bending and in tension and in compression, as well as its strength in shear. All of those properties are given in AS 1720.1, the timber design standard. Now, looking at each of those properties in turn, characteristic modulus of elasticity. The characteristic modulus of elasticity is the average modulus of elasticity for the entire grade. So every piece of timber may have a slightly different modulus of elasticity, but it's the average modulus of elasticity of all of the pieces of timber in the grade, or all of the timber products in the grade, that dictates what the average modulus of elasticity is. In terms of statistics, the mean is in the centre of the distribution, so that the modulus of elasticity that's quoted in AS 1720.1 for each of the grades is the average modulus of elasticity. That's a really good guide for the deflection of elements such as floor beams, where a large number of them work together to give the total deflection of the floor system. So it gives very reasonable estimations of the performance, the stiffness performance of timber in service. On the other hand, there are some cases where we're interested in how is the most flexible piece of timber actually going to perform. And those are the cases where the consequences of exceeding the deflection limits are going to lead to some kind of problem, either a structural problem or some damage to the building. As a result of that, for those instances, we're not going to use the average modulus of elasticity, we'll use a fifth percentile. And AS 1720.1 gives us guidance as to what the fifth percentile is for a number of different products. Now, in comparison, when we're looking at the strength of a piece of timber, the consequences of failure are much more severe. So we don't want the strength of the piece of timber to be exceeded. As a result of that, in design, we don't use the average strength, we use a fifth percentile strength as the basis of our design properties. So a fifth percentile strength way over the left-hand side of a statistical distribution is what we're going to use. And different products have got different distributions. Sawn timber has a wide range of strengths, and we're using a very conservative strength in the design of sawn timber. On the other hand, engineered wood products make use of a large number of wood fibres in the one product, and the strength distribution is much narrower, but we still use a conservative estimate of its strength for that particular product. The properties are dictated by the stress grade. So each stress grade has a name, and in the design standard there are tables that list all of the design properties. So here you can see an example of a table that is appropriate for sawn timber. So for sawn timber, we've got a number of different names of the stress grades, and reading across the table there are the properties of each of those stress grades. Bending strength, the tension strength parallel to the grain. So that's where the timber is being loaded by pulling it parallel to the grain. The shear in the member. So when we're loading it as a beam, we get shear in the member as well. Compression parallel to the grain. And of course, its modulus of elasticity. So they're all indicated, and they're all a function of the grade of the timber. And the grade is awarded to each piece of timber in the production of the piece of timber, and takes account of the strength of the fibres in the timber, and also things like knots and other characteristics that may appear in the timber in the growth of the timber in the tree. There are some properties in the timber that are not so much a function of the characteristics, like knots that are in individual pieces. They are only related to the character of the wood fibre. In order to assess those properties, and I'm thinking primarily about bearing strengths, so that's the strength where pieces of timber are sitting on top of a hard bearing surface. So that those bearing strengths are a function of the wood species. We look up a table in the standard that relates each species to a strength group. Once we've found the strength group, we can look up another table, and that gives us directly the bearing strengths of the timber. So some properties are given by the stress grade, others dictated by the species. For the MGP grades, which are essentially structural softwood grades, we can find both of them by looking up the same table. With a number of properties, they are a function of the size of the timber members. And for the MGP grades, each of the sizes are listed separately, and different bending, tension, compression and shear strengths are given for each of those sizes. So that's members. So we can use those properties to size members, to design members, to work out the capacity of members. Ultimately, in order to create a structure, we have to join members together. So connection strength is also important. In this slide here, you can see a number of different connections. The essential element of a connection is that it joins a number of members together, and we're transferring loads out of one member into another. And the timber has a vital role to play in the behaviour and the strength of the connection. In order to design connections and ensure that the timber is being loaded well within its capacity, we look up joint strength groups for each individual species, so that we can look up a table that has the species down the left-hand side, and as well as the strength group, it also gives the joint strength group of those species. The joint strength group is then used to design connections between members. So in summary, stress grades are awarded in the production of structural timber elements. That those stress grades can be used to relate the structural timber to its characteristic strengths and its characteristic modulus of elasticity. The characteristic modulus of elasticity published for every structural timber element is based on its average, and the characteristic strengths are based on the 5th percentile. They are a conservative estimate of what we're going to see out of the whole population of that particular stress grade. As well as that, species are going to be used to give us the bearing strength and the joint strength that we're going to use also in designing the details of each and every structural member.